Hello everyone, welcome to this video. This is our second video on Pthreads. In this one, we'll be talking more about mutex lock and synchronization, and it's basically continuation on the previous uh, session on Pthreads, in which we generated prime numbers and with uh, with with the restriction on the number of try the thread has to generate a prime number. But in this one, we actually are focusing on uh, getting 10 prime numbers, and it doesn't matter how many threads work together. The code structure architecture is similar, but we have another mutex variable that stores the prime value. So in this one, the number of threads, it can vary. The number of tries, it's similar. So in this one, we define a new variable called number values. So we want uh, all the threads to work together and generate 10 prime numbers. And for that, we are defining some global shared variables that are shared among all the threads. And the first one is prime values, which stores the prime values, and it has a size of number of values. And initially, the number of values count has been set to 1, which increases if any of the threads generate a prime number. And then we are creating a mutex variable called values or mutex, which basically is a restriction, like it until the only one of the threads can access this variable and change its value. And then there is a condition on that, that is value, the condition that is managed by the master node. And once these 10 prime numbers are generated, we can send a cancel request to the master thread so that it can cancel out all the following threads. So right now it's 0, so there is no cancellation for threads. So similarly, we are creating a barrier function for locking and unlocking the mutex. So here, initializing the mutex with count and number of threads, then destroying the barrier, and then barrier dot wait until the condition is met. So the major changes will be this is same as prime to check whether the number is prime or not. And yeah, so here is this is a new function which adds the a new prime number whenever it is generated to the values to the array that we defined earlier. Yeah, prime numbers. So initially it has logged the values of mutex. So then it checks how many prime numbers are there. So if we have reached the values of count has reached the number of values that is the maximum, then uh, if number of values is count is greater than or equal to, then it unlocks so it can move further. Otherwise, it remains locked. Then lock means like only one thread can access it and change the value. So if the condition is not met, then uh, prime values, we store the prime number if the prime number is generated. It is conditional. If the prime number is generated, then only this add prime is called. Otherwise, it won't be called, and we increase the counter. Then it checks the target. If the target is meet, then pthread will unlock the variable values dot mutex, and your main thread can destroy all the following threads. And then it's if this unlocks, then it sends a signal to the master thread that the number of that our condition is met, and then you can destroy the following threads. So this is a thread function. This is, I think it will be more or less similar. So here we are checking for maximum tries, and we are checking for the prime, and if add and try to add prime. So if we if it is prime, then it adds a prime to our global variable. Else it will print that it could not find the prime number. And it uses a nano sleep to reduce the CPU time. So it basically gives you some time for CPU. So let's go further. I have something else. So this is how it works. So you have the main thread which initializes your mutex and conditional variable in your array, and then it creates the threads. Then each thread will run the isPrime function, and if it generates a prime number, it so see if all these are generated, so they will try to access the add prime, and but it is conditioned, so only one thread at a time can access it and change its value. So and once your target is reached, then the master thread is called upon, which basically destroys the threads, and you exit the loop. And then pthread.join to all join all the threads, and then you destroy the section. So over here we are creating a barrier that thread arguments for number of threads, giving foreign type by number minus. And yes, so initially all the prime values are 0. We are initializing the barrier. Uh, then we're creating the threads. We are assigning this where they are all running a copy of start function. Then master thread waits for conditional variable, so mutex lock on values. And if this is less than that, so waiting for more primes. While, and then if this condition is met, then the mutex unlocks, and now the target has reached and it has cancelled all other threads. And then it joins all the threads, and after that it stops. We are measuring the time, and then we are printing the results. And after that, we are destroying the barriers and mutex and conditional variables and mutex variables. So to compile this, we'll be using similar to the previous exercise. We'll be using this. So let me just put it over here. Okay, so let's see. Also, I think the name is different, so that's why. Let's call it prime. Let's see. Minus so prime.exe minus L with thread minus L. Mm, okay, so, yeah, this was the error. Yeah, sometimes it happens during copy and paste. Some of the things are missed. Yeah, so you can see over here, what is happening is that we have started with 4 threads to find 10 primes. Uh, these 2 threads have started. So thread 2 has been searching. Then so master thread also So you can see these works in parallel. So master thread is checking, all other threads are working. So once it is found, it is added to the array and similarly, and then your target has reached and it is cancelling all other threads. And although others were working in parallel and they found the prime, but they could not add because the matrix is full. And this execution took around this much time. Yeah. So let's see what else over here. Yeah, this is results with different number of threads, and I think there is a plot. So yeah, if you see that if you increase the number of threads, your time decreases. So because you have more threads working on the same problem. So it will give you a speed up. Okay, so thank you everyone for watching this video, and I'll be providing the link to this code and to this particular document in the description.